Hello, my name is Caitlin Rodriguez Rivera, and this is my Physics 2212 public lecture review. The lecture I selected from the archive was given by John Weiss, faculty at Georgia Tech and director of the Center for Relativistic Astrophysics. Weiss, who completed a NASA postdoctoral fellowship at Goddard Space Flight Center under John Mather, focuses on how galaxies like our very own Milky Way formed over billions of years. The lecture's main idea surrounds how large galaxies do not form all at once and are instead built up from much smaller baby galaxies early in the universe. These young galaxies, along with young stars, serve a crucial role in shaping all we see in the universe today. Wise's lecture begins by explaining how light takes time to travel, allowing us to look back into time when we observe distant galaxies. For instance, light from the Andromeda Galaxy takes around 2.5 million years to reach us, and allows astronomers to study how galaxies evolved over time. Another key concept discussed was redshift, which occurs due to the universe expanding. As light travels through space, its wavelength stretches and allows scientists to measure how far away galaxies are. Using this technique, astronomers created detailed images like the Hubble Ultra Deep Field that revealed thousands of galaxies in a tiny patch of sky. Additionally, the lecture covered the early universe, beginning with the Big Bang, and with it the creation of matter, space, and time. Recombination occurred and temperatures dropped. Electrons and protons became neutral hydrogen, and the universe became transparent. It's followed by a period referred to as the Dark Ages, when no stars or galaxies existed. After the Dark Ages, matter began to clump together and form structures. Eventually, the first stars were formed, which were massive but short-lived. These stars produced the first heavy elements through supernova explosions, which then allowed more complex galaxies to form. Finally, Speaker Weiss explained that galaxies form through a process called hierarchical merging, in which small galaxies combine to form larger ones, and over billions of years this process led to the formation of galaxies like the Milky Way. By watching this lecture, I was able to learn that observing very distant galaxies, we are actually looking back in time. It helped me cement how powerful it is, since scientists and astronomers are able to study what the universe looked like just a few 100 million years after the Big Bang. It was also fascinating to realize that all elements heavier than hydrogen and helium, like the ones in our bodies, were created inside stars and spread through supernova explosions, therefore making us of material that originated from the first generation of stars. Overall, this topic was of interest to me since I have always enjoyed staring into the night sky and would hope to one day visit a stargazing location with minimal light pollution like Chile's Atacama Desert to witness an unperturbed image of the starry night. In Wise's lecture, he mentioned the James Webb Space Telescope, which is designed to observe very distant galaxies. It has already identified galaxies like Jade's G5 Z13-0, which was observed less than 400 million years after the Big Bang, allowing scientists to push closer to the era of the first galaxy formation. Earlier still, the Hubble Space Telescope discovered galaxies such as GNZ11, which was one of the most known distant galaxies for a long time. We could also connect to exoplanets and the possibility of life, since galaxies form through merging and star formation, and since most stars appear to have planets, understanding how galaxy formation could help us understand how common planetary systems are throughout the universe. For instance, the TRAPPIST-1 system is a star system with 7 Earth-sized planets, in which several are in the habitable zone. Thank you for listening.